title, isn't it? It may surprise you with all those things that I get involved in. I see my wife occasionally as well. That they're all technology, but you know, I don't like technology. I have no interest whatsoever in how technology works. The only thing that interests me is what technology can do for us. Part of the problem, I think, is that when you're working in this technology environment, there's lots of jargon. I hate jargon. I don't know if anybody agrees with me. But the technology industry and things like BIM and the things we're talking about today are shrouded in jargon. And it causes me miscommunication. Let me give you an example. A friend of mine is a plumber. And he's a very conscientious plumber. Don't laugh, such things do exist. And he had a job recently where he had some blockage in some of the metallic drain systems that he was working with. And he thought, well, I need to get something to clear this. So he decided that he wanted to use a dilute solution of sulfuric acid to clear out the drains. But being conscientious, he wrote to the local planners and he said, you know, I'd like to use a 1 in 20 solution of sulfuric acid to solve this problem. Is that okay? And the planning authority wrote back to him and said that the efficacy of sulfuric acid was incompatible with metallic permanence. So confused, he wrote back and said, thank you for your response. So does this mean I can use sulfuric acid to clear out the drains? And the second response was, when considering the use of erosive or corrosive substances for the purpose of cleansing building products, one should always consider alternative procedures as a contemporaneous activity. So confused, he wrote back and said, thank you for your second response. Does this mean I can use sulfuric acid to clear out the drains? And the third response came from somebody who actually knew what they were talking about, and it was something along the lines of, don't use sulfuric acid, it eats the shit out of metal. Now, at that point, communication took place, and when I look at this, and there's a lot of technology behind this, I'm going to keep this very, very simple. I'm going to go back to basics, because that way I understand it, and as my wife said, if I can understand something, then anybody with a mark of intelligence can understand it. So, what are we going to look at? First of all, the change in data market, how construction is meeting the challenge, and this is going to be very construction focused, although it will obviously incorporate into the wider big data. So I'm going to look very briefly at building information modelling, the standards and protocols which surround that, and something called AFC, which is an interoperable communication protocol. That's about as complicated as this presentation gets, ladies and gentlemen. But what is it, why is it needed, and why will it succeed? How is that relevant to city planning? And what needs to happen as we move forward? So let me start with the top, the changing data market. The industry is changing. And how is it changing? Well, we're very, very good at creating data. We have loads of data. In the construction industry, we have hundreds of authoring tools which bombard us with data. Creating it is no problem. But there is a problem in that creating data is a cost. It doesn't actually do anything until we exploit or use that data. So what we have to do is to try and find a way of linking the data that we've got with a usable, integrated data that we can use and extract value from. This is the way that the current technology industry has tried to address it. And anybody who's worked in this field will understand exactly what I mean by that. This is not to deter the technology providers out there, it's just a fact of life, it's a reality. So what do we need to do? Well, as I said, I'm a very, very simple soul. And when I look at a project, whether it be a city, or whether it be something as simple as a building, then that project I try to visualise as a picture. The completed project is a picture. Now, if we start from that premise, let's think of it as a jigsaw puzzle. We all know the best way to complete and make a jigsaw puzzle is to start with a picture and to stamp out the pieces, that way they all fit. In a construction project, however, we can't do that. We have to start by creating the pieces themselves and creating them in such a way that those pieces will firstly fit together, and equally importantly, that the data on those individual pieces relates to the data that surrounds it. Logical? That's the way that we actually work. So in terms of this, we have to create data and create a picture which will enable us to exploit that data. And there's lots of things we have to do in the process to make that happen. I'm just going to lump them under two headings. One is federation, which is the ability to bring data together, and the other one is quality assurance, which is the ability to ensure that the data is correct. and relates to the data that's around it. So that's how I view a construction project. Maybe a bit simple for a city and big data, but basically that's all we're doing. So, the solution that the construction industry is increasingly adopting is BIM. We've all heard of BIM, Building Information Modelling. Or is it Building Information Modelling? I believe it is, because Building Information Modelling is the starting point. That is the process. Building Information Modelling is the process which enables us to create data in such a way that everybody has access to the information they need when they need it. That was a definition I used for BIM in 10 words. Access to the information you need when you need it. And you could say, that's too simple. Let me ask you a question. How many people in this room involved in construction have access to the information they need when they need it? All the time. Anybody? Some of the time. Maybe. Most of the time you don't. That's probably nearer the mark. So the process has to come first. I've seen countless companies fall flat implementing BIM when they go straight to the second part, which is creating a building information model. The building information model itself, which is very much a computer image of a virtual project, that's all it is the output of the process. So if it's something you're embarking on, for goodness sake, start here. Don't start there. If you start by just creating a model, you will fail. I'm 100% certain of that. Okay, so we have a process. So that's BIM, Building Information Modelling. We have a model. That's BIM, that's a Building Information Model. Where's the playback? It's in the third bit, Building Information Management. It's how we use the data that has been created by this process to actually enable us to build and manage a facility. So that's the payback. So BIM, there's actually 3 parts of BIM. In fact, I've seen BIM described as BIM-M, Building Information Modelling and Management. And that's probably nearer the truth than Building Information Modelling. Okay, so a brief recap. So if that's BIM, to succeed, we need to be able to do something. And the first and most important thing is, we have to have the willingness to change. BIM is a new way of working for this industry. The way that we normally work is by, excuse me, I'm cynical, but keeping data to oneself and not trusting anybody in the process. That's the way this industry has evolved. BIM requires the opposite. It requires the ability to work with people and to trust and share information. If we don't do that, again, BIM won't succeed. We need something to help us, and this is where the government has been very proactive and very helpful by giving us a series of standards and guidelines which will enable those embarking on the BIM journey for the first time to work in the right way. So we need that. And the outcome of that, and Tim alluded to already, is something called the Level 2 legacy. So we have that now in the system. We need a way of describing the data in construction. We need to be able to have the ability, excuse me, to say that a door is a door, irrespective of the tool that's creating the image of that door or the data sitting behind it. We need to be able to understand. So we have to have a common way of naming things. Again, this is all very logical. And we need to have a way to communicate it, and that's what I'm here to talk about today. An open, interoperable means of communicating data. So, when we look at that, we have to create something called a communication protocol. And there are only 3 ways we can do that. We can do it in a bespoke way, we can do it as a single platform, sometimes called closed BIM, or we can do it with a common platform, sometimes called open BIM. What the hell does that lot mean? That's jargon. Let me try and simplify it. United Nations, we've all heard of the United Nations, I hope. We all know what the United Nations is. It's actually 192 sovereign countries that between them speak 50 different languages. What the United Nations does is another matter, but I'll never quite work that one out. But let's have a look at the UN. How do they tackle the communication protocol problem? Well, I'm not going to take 192 countries, I'm going to take 4. I'm going to just select those at random because they're 4 languages. So we've got China, Spain, France and Germany. Now, if they are going to communicate, then we have to find a way that they can understand each other. And the first way we can do that is quite simple. Everybody learns everybody else's language. Simple. Anybody speak 4 languages? Actually, I've asked that question. Somebody once put their hand up and said, I speak 7. And I said, that's very good, you speak 15. That shut them up straight away. But basically, everybody learning everybody else's language, that would work. That is called a bespoke communication system. And in technology terms, what it means is if you have different technology platforms, you have a bespoke communication protocol to enable them to exchange data. It works, but it's very complex. And every time the software changes, we have to start all over again and create a new protocol. But it is a solution, so I put it up there. There's another thing we can do. This might be a bit scary, actually. Everybody, except one, has to change their language. So we all speak Chinese now. That would work, wouldn't it? Actually, we tried it in Europe. Anybody heard of Esperanto? Yeah, Esperanto. Charles de Gaulle, I think it was, in the mid-60s, said that by the turn of the century, everybody in Europe will speak Esperanto. There is more Klingon spoken in Europe than Esperanto. We are not going to give up our sovereignty, but that is a solution, and that's called a single platform, or closed BIM. That's the one the technology providers would like you to do. Forget everybody else's product, just buy our product, because our products can talk to each other. They don't actually, but that's beside the point. It's a solution, so let's just leave it there. There's another way of doing it, and that is everybody uses their own language and has a common interpreter. And that's more appealing, isn't it? We don't have to do anything. And as we know, that's the way the United Nations actually works. So if I'm stood up at the front of the UN speaking in English, there's a bank of translators at the back of the room which put into the headphones the native language of the recipient. So the Chinese delegate will be able to hear in Chinese instantly what I'm saying in English. What a good idea. If we could do that with technology, what a great idea. That's called a common platform, or in technology terms, Open BIM. And we do have a solution, and the solution is this thing called Industry Foundation Classes. It's basically a way, it's Babelfish, if anybody remembers the Hitchhiker's Guide to the Galaxy, where you put a fish in here and instantly you can understand any language. That's what IFC is, it's a Babelfish. It enables authoring tools to create data, transfer it into IFC, which can then be absorbed by other authoring tools so they can exchange data. What a good idea. It's out there, it works, believe it or not. Why will it succeed? A number of reasons. The first one is it will allow users of technology to select the technology which best meets their particular needs. So they can simply say, that's the technology I want, it's the best in class and most fit for my purpose. Doesn't matter about communication with other systems because we have IFC. Competition. Technology relies upon competition. It's essential. So, an example, if we didn't have competition, VHS, video recording, remember that? In 1980 there was only one system, became VHS. Between 1980 when VHS was adopted as the global standard and 2005 or thereabouts when DVDs took over, what technology advances were made? None. We actually had double tape speed, which nobody used because it was crap basically, but there was no technology advance made. If we don't have competition, the industry is dead. Open communication platforms mean that we have competition because now everybody can develop their own specialities and it will communicate. Application. There are hundreds of softwares out there. It is impossible to think that one software can actually solve all the problems. So we have multiple applications. We have to have a communication protocol. And finally, everybody else does it. Where would the web be without HTML? Where would we be looking at pictures without JPEG? Okay, not direct analogy, but a similar concept. We have a common way of looking and sharing data. So that's why IFC will succeed. So let's look at this original problem that we started with. We need to be able to federate, we need to have quality assurance. We have the things that help us with that, so PAS 1192, which is the government guideline for BIM, classification systems, and IFC. If we implement those things correctly, then that problem disappears. So that's why IFC is important. How does it relate to big data? How does it relate to smart city planning? Well, Tim started to define this in far more detail than I did, but if we start with that statement, so smart cities really is the function of management of an entity, cost effectiveness, sustainability, reliability, standards, all of these sort of things. If we start with that, then building and infrastructure and utilities data has to be integrated. We can't achieve a lot of the things we want to unless we can start sharing data between these different things. So let's give it some examples of that. Really, this is pretty much the end of what I've got to say. If we start with authoring tools, and we've got the things that we know, the architectural, the structural, the infra, the city planning tools, the electrical, all of those sort of things. That's creating data. We're very good at that. This is what we need to be able to do. We need to be able to use them for things like cost estimation, if we've got any estimators left. I don't know if we will have. But maintenance, scheduling, building code checking, site safety, area code, all of these things. That's the payback when we can use it. So with IFC, it helps to make the process possible by linking these things together, and supported with these standards and classification systems will enable us to transfer from what we create into what we can use. And that's why IFC is so important. buildingSMART's role in this, well, buildingSMART actually own IFC. It's a schema. We've quite understood what that word means. But it's an ISO standard, and it's functional, it's robust, it's been around for a number of years, and it's improving all the time. It's there, it exists. It has associated subsets, something called COBE. Anybody heard of COBE? You must have heard of COBE. Of course, COBE, to the buildingSMART community, is simply a subset of IFC. So if you try to create COBE data and you don't go the IFC route, then it's a bit like taking a bus from here to Westminster via Glasgow. You'll get there, but it'll take you a lot longer. So that's another reason why we should work it. We don't have at buildingSMART yet the same level of capability for IFC in infrastructure. This is something that, as an organisation, we're working with, and we're working globally on this to ensure that it works. So really what we have to do, the process has started, especially in terms of the infrastructure, but it needs ongoing industry support, and that's something that we're getting. That basically is all I've got to say, but thought for the day, and I think you said it, we were talking about this morning, weren't we? Reginald, the Reverend Nigel Blue, was it, who did the thought for the day on Radio 4? For me, it's quite simple. In this world of big data, we're creating far more information than ever before. If that information is not correct, potentially we're creating far more problems than ever before. We have to find a way of both communicating that data and ensuring that that data is correct. Thank you.
Perfect. Thank you. Thank you, David.